Journeying billions of miles into space is a task reserved for spacecraft, and NASA's Voyager 1 has been one of the most dependable vessels to explore the cosmos as it traverses the depths of the universe. Voyager 1 is causing scientists to raise their eyebrows by transmitting peculiar signals from its current location a staggering 23 billion kilometers away. The enigmatic signals beg the question, is there a glitch in Voyager 1's system, or is it faithfully executing its mission by sending crucial warning signals back to Earth? Join us as we unravel the events that transpired just 3 minutes ago when Voyager 1 turned back, making a terrifying discovery. Modern humans have surpassed the wildest imaginations of our ancestors for millennia. Billions of humans gazed at the moon, never imagining the possibility of setting foot on it. Yet, through incredible inventions stemming from the tireless efforts of brilliant scientists and engineers, achievements once deemed unimaginable are now within our grasp. Organizations like SpaceX and NASA are pushing the boundaries, targeting missions to Mars and propelling us further into space. While the objectives of these missions may vary, landing on Mars represents a pivotal moment that will significantly expand our reach into deep space. Nevertheless, inherent limitations to what human space travelers can accomplish exist. The vastness of the universe beckons us to explore numerous phenomena, many of which would take us billions of miles away from our only comfortable abode, Earth. This is where space probes come into play, serving as our eye in places beyond our technological reach. Voyager 1, launched 4.5 decades ago, stands as a timeless observer in the vastness of space, together with its counterpart Voyager 2. The Voyager missions serve as historical capsules that encapsulated the essence of their era and captivated the public's imagination during the 1970s and 80s. As humanity's pioneering envoys to the outer planets, the Voyager missions demand acknowledgement for offering unparalleled scientific returns. Voyager 1, in particular, proudly holds the title of the first spacecraft to leave the solar system and venture into interstellar space. Launched in September 1977, Voyager 1 roams more than 14.6 billion miles or 23.5 billion kilometers away from Earth, cementing its position as the most distant spacecraft from our home planet. Its trajectory symbolizes the apex of human innovation and exploration. NASA's Jet Propulsion Laboratory reported that the spacecraft is steadily propelling itself away from us at an impressive speed. Voyager 1 is currently zooming through space at 38,000 miles per hour or 17 kilometers per second. Notably, the significance of Voyager 1 endures even 45 years after embarking on its mission to explore the outer planets of our solar system. One landmark achievement for the spacecraft happened when it entered into interstellar space in August 2012, marking almost 35 years into its journey. However, this groundbreaking discovery was not revealed until 2013, allowing scientists sufficient time to thoroughly analyze the data returned. Learned by Voyager 1, serving as the second of the twin spacecraft to be launched, Voyager 1 was the first to race between Jupiter and Saturn. For a generation, the images sent back by Voyager 1 have become integral in school textbooks and numerous media outlets. Notably, the spacecraft carries a unique artifact known as the Golden Record, designed to convey voices and music from Earth into space with the hopeful notion that sentient extraterrestrial beings might detect and take interest. Compiled by a committee led by astronomer Carl Sagan, the Golden Record includes greetings in 55 different languages, along with diverse traditional music from various cultures. It features a greatest hits collection of classical music as well as Chuck Berry's Johnny B. Good and a jazz number by Louis Armstrong. A fascinating aspect of the Voyager missions is the inclusion of a way for potential alien discoverers to learn how long the probe has been in space through a uranium-238 fragment attached to the main bus near the record. However, some express concerns that any hostile alien stumbling upon the Voyager disk might find a map leading them directly to Earth. While this may seem alarming, the Voyagers will spend tens of thousands of years in interstellar space before reaching another star, rendering their situation far from urgent. If the disks are ever discovered, it might be in a distant future where humans may no longer exist. An enduring aspect of the Voyagers is their endurance in the universe. Even after ceasing to work or transmit, they will outlast use. With no atmosphere in space, there is no corrosion, and in interstellar space, there is little for them to collide with. One of the most noteworthy accomplishments of Voyager 1 was the Grand Tour, made possible by an unusual feature. The Voyager missions capitalized on a rare alignment of the outer planets that occurs once every 176 years. This celestial alignment provided a strategic opportunity for the spacecraft to employ slingshot maneuvers, seamlessly navigating from one planet to the next while maximizing their utilization of limited fuel. Initially, NASA envisioned an ambitious initiative involving 2 probes charting courses past Jupiter, Saturn, and Pluto, and an additional pair venturing past Jupiter, Uranus, and Neptune. Regrettably, budgetary limitations compelled NASA to scale down these ambitious plans. Despite these limitations, the 2 Voyager spacecraft achieved significant milestones. Voyager 2 completed flybys of Jupiter, Saturn, Uranus, and Neptune, while Voyager 1, staying close to Jupiter and Saturn, almost faced a significant setback during its launch. Its rockets came within 3.5 seconds of running out of fuel. However, the probe successfully entered space and swiftly outpaced its twin, passing through the main asteroid belt between Mars and Jupiter before Voyager 2. Voyager 1 achieved remarkable milestones by delivering Earth its initial glimpses of Jupiter in April 1978, capturing global excitement from a distance of 165 million miles or 266 million kilometers. The revelation triggered celebrations worldwide. Subsequently, in March 1979, Voyager 1 made a startling breakthrough by uncovering a delicate ring encircling the colossal planet. Additionally, the probe identified 2 previously unknown moons, Thebe and Métis. Noteworthy is that Voyager 1 also transmitted intricate images of Jupiter's prominent Galilean moons Io, Europa, Ganymede, and Callisto, alongside details of the gas giant itself. Like the pioneering work of the first spacecraft that preceded it, Voyager 1 brought to light the active nature of Jupiter's moons, portraying them as dynamic worlds in their own right. Voyager 1 also unearthed fascinating facts about these natural satellites, showcasing Io's numerous volcanoes and mottled yellow-brown-orange surface. These discoveries underscored that moons similar to planets can have active interiors, adding to the wealth of knowledge garnered by the Voyager spacecraft. Moreover, Voyager 1 captured and transmitted images of Europa, revealing a seemingly smooth surface marked by lines suggesting ice formations and hinting at the possibility of an underlying ocean. Subsequent observations and analyses indicated that Europa likely harbors a vast subsurface ocean of liquid water capable of supporting life. In March 1979, Voyager 1 executed its closest approach to Jupiter, reaching within 74,000 miles or 280,000 kilometers of the turbulent cloud tops. Redirected toward Saturn, the probe provided close-up images of the ringed planet from 1980 onwards. Saturn, like Jupiter, presented unforeseen phenomena, including the discovery of the ethereal F ring, a structure identified just a year earlier by NASA's Pioneer 11.